Hi everyone, today we are going to start 8.1, which is find angle measures in polygons. Consecutive vertices. Consecutive vertices are endpoints on the same side of a polygon. So for example, A and B are endpoints, and if I connect them, these would be consecutive vertices. Diagonal. A diagonal is a segment that joins non-consecutive vertices. So if we start at B and we draw a segment all the way to endpoint D, that would be a diagonal. If we start at B and draw to our other non-consecutive vertice, endpoint E, that would be our second diagonal. Polygon interior angles theorem. The sum of the measure of the interior angles of a convex n-gon is n minus 2 times 180. Remember n-gon? N just represents the number of sides the polygon has. So this is our equation to determine the interior angles of that certain polygon. So if you look here, I have a list of different polygons depending on their number of sides. So first, a three-sided polygon is called a triangle. So if I wanted to figure out what is the sum of the interior angles of a triangle, I'm going to use my equation here. N minus 2 times 180. Well, the number of sides is 3. So 3 minus 2 times 180. You can plug this right into your calculator, and when you do so, you get 180 degrees, which we already knew that the interior angles of a triangle add up to 180. Let's move on to a four-sided polygon, which is called a quadrilateral. So if I plug 4 in for n, 4 minus 2 times 180, plug that right into your calculator, we get 360 degrees. So the sum of the interior angles of a quadrilateral is 360 degrees. I'm going to pause the video and I'm going to do the same thing for 5, 6, and 10. Alright, so I finished filling out this diagram. So a five-sided polygon is called a pentagon, and when you plug 5 in for n, you end up getting that the sum of the interior angles of a pentagon is 540 degrees. A six-sided polygon is a hexagon, and when you plug that into your equation, we find out that the sum of the interior angles of a hexagon is 720 degrees. And finally, a 10-sided polygon, also known as a decagon, the sum of the interior angles of a decagon is 1,440 degrees. So this equation will work on any polygon that you can think of. Find the sum of the measure of an interior angle of a convex octagon. So first we have this word octagon. So how many sides are in an octagon? Well, that would be 8. So 8-sided polygon is an octagon. So I'm going to plug that into my equation, the n minus 2 times 180. That equation gives you the sum of the interior angles. So instead of n, I'm going to plug in 8. So 8 minus 2 times 180. Plug that right into your calculator, you get 1,080 degrees. So the sum of the angles in an octagon is 1,080 degrees. The sum of the measures of the interior angles of a convex polygon is 900 degrees. Classify the polygon by the number of sides. So this time we're going to work backwards. This time we know the sum, but we don't know the name of the polygon. So let's remember that our equation is n minus 2 times 180 is equal to the sum of the measures of the interior angles. And in this case, we know that the sum is 900 degrees. So now I need to solve for n. So if I wanted to get n by itself, what would be my first step? Well, it would be to get rid of this multiplication of 180. So I need to divide by 180 on each side so that those cancel. When I do so, I end up getting that n minus 2 is equal to 900 divided by 180 gives us 5. N is still not by itself, so I need to add 2 to each side. Add 2 to each side. and n then is equal to 7. What type of polygon is a 7-sided shape? It'd be a heptagon. Let's try a similar problem. So the sum of the measures of the interior angles of a convex polygon is 1,440. Classify the polygon by the number of sides. So once again, we're given the sum of the interior angles, but we're not given what type of polygon we have. So our equation is n minus 2 times 180, and that's going to equal our sum of the interior angles, which in our example is 1,440 degrees. Just like the last problem, my first step is to divide by 180 on each side so that cancels. I'm left with n minus 2 is equal to, we get 8. I need to add 2 to each side, and we end up getting that n is equal to 10. What type of shape is a 10-sided polygon? That would be a decagon. All right, next we're going to solve for the value of x. So we have a shape here. What type of shape or polygon do I have? We have a quadrilateral, and I see that because there's 4 sides. 1, 2, 3, and 4. I also see some interior angles, and I need to figure out what is x, and x is an interior angle. So before I start this problem, I need to think to myself, what is the sum of the interior angles of a quadrilateral? Well, if you can't think of it right away, let's use our equation. So n minus 2 times 180. Well, we said that n is 4, so 4 minus 2 times 180. That gives us 360 degrees. So I know that the sum of this polygon has to equal 360 degrees. So now I can set up my equation. So I know that x, which is one of my angle measures, plus 108, which is my second angle measure, plus 121, which is my third angle measure, plus 59, which is my fourth angle measure. When you add all those up, it must equal 360 degrees. So now we just need to solve for x. So let's add these up. When you do so, we get x plus 288 is equal to 360. Subtract 288 from each side. Subtract 288. And we get that x is equal to 72. Find the measure of angle S and angle T. If you look at your diagram, we notice that S and T both have these tick marks. So what does that mean about the measures of both those angles? It means that they are congruent. So I'm actually going to call both of these X. All right, so next I have a polygon here. I'm looking at my polygon and I notice that we're talking about my angles, my interior angles. So I need to figure out what is the sum of the interior angles. Well, first off, what type of shape do I have here? Let's count the sides. 1, 2, 3, 4, 5. So I have a pentagon. So if you don't know the interior angles of a pentagon, let's use our equation. So 5 minus 2 times 180. You plug that into your calculator and you end up getting that the interior angles of a pentagon is 540. All right, so now that I know what it needs to add up to, I just need to take all of my angle measures and add them up. So one angle is x. I have another angle, which is also x. No, and I'm adding, sorry. Plus, I have an angle of 93. Plus, I have an angle of 156. Plus, I have an angle of 85. When we add all those together, we better get 540. Since I have two x's here, that just means this becomes 2x. Plus, I'm going to add these all up. And when I add them up, I get 334 is equal to 540. Subtract 334 from each side, and I end up getting that 2x is equal to 206. So to get x, I need to divide by 2 on each side, and I end up getting that x is equal to 103 degrees. So what does that mean? It means that both angle S and angle T both are 103 degrees. If we want to find any angle in a regular polygon, we're going to use this equation. Now remember, a regular polygon means that all the sides and angle measures are congruent. So if I know the interior angles, the sum of the interior angles, which is, this equation here, if I want to figure out what is one specific angle in that polygon, I would divide it by the number of sides. So for example, let's go back to our pentagon problem. So we know that a pentagon, the sum is 540 degrees. And let's prove it by using our equation. So 5 minus 2 times 180. If I want to divide that by the number of sides to figure out what is one angle measure in that polygon, I would change this n to a 5. Got to change that to a 5 because there are 5 angles. When you plug that in your calculator, we end up getting 108 degrees. So what does that mean? It means that each angle in a regular pentagon would be 108 degrees. Next, we're going to talk about polygon exterior angle theorem, and that just states the sum of the measures of the exterior angles of a convex polygon, one angle at each vertex, is 360 degrees. This means no matter which polygon you're looking at, we automatically know that the exterior angles, the outside angles, will add up to 360. This will always happen. So what is the value of x in this diagram? Well, looking at my picture, I notice that I'm looking at exterior angles. So since I'm looking at exterior angles, what will all those exterior angles add up to? 360. So I'll start at this angle here. I have x plus my next angle, 2x, plus my third angle, 89, plus my fourth angle, 67. That all is going to equal 360. Let's combine our like terms. 1x plus 2x is 3x. 89 plus 67. That gives me 156. We know it's equal to 360. Subtract 156 from each side. I get 3x is equal to 204. Divide by 3, divide by 3. We end up getting that x is equal to 68. And for the last problem here, a convex hexagon has exterior angles with the measure of 34, 49, 58, 67, and 75. What's the measure of an exterior angle for the sixth vertex? All right, so I only have 1, 2, 3, 4, 5 of them. I need to figure out what is the sixth. Well, since we're talking about exterior angles, what will all the exterior angles add up to? 360. So I have x, which I'm looking for, plus 34, plus 49, plus 58, plus 67, plus 75. That's equal to 360. Let's see if you can figure out what is x. And you should get that x is equal to 77.